we need to prove the identity 2 cot 2x plus tan x is identical to cot x. So I notice that I've got a double angle here. So I want to be able to use the double angle formulae to turn that into a single angle. So starting on the left-hand side, I'm going to rewrite cot 2x as being cos 2x over sine 2x. Now I can also rewrite the tan as being sine over cos. Next step, let's deal with these double angles. Now, I'm not entirely sure which version of the cos double angle to use yet, so let's leave that alone for now. Let's focus on the sine 2x, because there's only one way I can write that. So let's do that. So on the top, I've got the 2 cos 2x. I know that sine 2x is 2 sine x cos x. Right, now I can see that 2 and that 2 are going to cancel. Now it might be helpful at this stage for me to get a common denominator, so I can bring these two fractions together to be a single fraction. Because at the end of this process I want to end up with just the cot t, just one term. So I don't want two fractions, I want one fraction. So I'm going to times this second fraction by sine x, so that I have a common denominator of sine x cos x. So that leaves me with, on my numerator, cos 2x plus sine squared x over sine x cos x. Right, now I need to do something with this cos 2x. How could I rewrite that? I'm going to rewrite that as 1 minus 2 sine squared x. The reason I've chosen to do that one is so that I can combine it with the other sine squared. Now I can see that my numerator is going to simplify. The 2 sine squared x plus sine squared x is just going to be the minus 1 sine squared, which is the same. 1 minus sine squared is the same thing as cos squared. And now I can see that actually this cos here is going to cancel with one of those coses on the top, to just leave cos x over sine x, which is indeed identical to cot x. And we're done.